Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So today we're from first group of electrical engineering of H class will present you about the task of English compulsory task, which is academic presentation, and we're gonna present you about Newton's law theory. And get to know more about our team consists of 5 members. First, Marshanda Alfa Amaria. Second, Sabriansyah Zhafron. Third, Irfansyah Bintang Wibawa. And fourth, Syauqi Ghiffari Rachman. And fifth, Nababi Nafi Ashari. Today's presentation topics include Newton's law, force and mass, wake and contact force, free body diagrams, and also problems related to the Newton's law. So we're gonna present you about this topic. To begin the presentation, please welcome Ali to explain the first material.
Okay. Newton's law is one of the rules applied in physics. An object in motion cannot be explained by logic. But if you use Newton's law, you can calculate its speed and distance. Next. Newton's first law. An object that is initially at rest will maintain its state of rest or lazy to move. And an object that is initially in motion will maintain its state of motion or lazy to stop. The property of an object that tends to maintain its state of motion is called inertia or laziness. The formula of Newton's first law is sigma of force equals to 0.
And then for the Newton's second law will be explained by Syauqi.
Okay, the Newton's second law. In the Newton's second law, acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. Or we can say that the net force is the product of mass and acceleration. The next. And then the third law of motion. The question is, what happens when two objects interact with each other? If one object exerts a force on another object, the object that is subjected to the force will exert in a force equal in magnitude but opposite in direction. Or we can say that every action has an equal and opposite reaction. Next.
And then the next material, we're gonna know about force, mass, and also wake. To calculate mass, we need to know the gravitational force acting on the object and its wake, right? And then we can calculate mass by following this equation. We know that this triangle consists of mass, wake, and also gravitational force. So to read the equation, we can see that wake equal to mass multiplied by gravitational force, mass equal wake per gravitational force, and gravitational force equals to wake per mass. Force. What is force? This means that the force is a vector quantity that has both a value and direction. Force causes an object to undergo a certain changes. For example, changes in speed, changes in directions, changes in the motion of object, changes in the form of object, and so on and so forth. And then, what is mass? Mass is a measure of how much matter is in object. Mass measures in the kilograms. And also weight. Weight is a measure of an object force pressing on the surface because of gravity. Weight is measured in the newtons. So in the basics, of course, mass and weight are two different things. The difference between mass and weight is that mass is amount of matter in the material, where weight is a measure of how the gravitational force acts on the mass. For the next material will be explained by Bintang.
What is the contact force? Contact force is a force that is applied by objects in contact with each other. There are three contact forces that we will discuss, starting from solid, spring, and string. Solid, such a force perpendicular to the contacting surface, usually known as the normal force. And spring, when a spring is a stretch from its unstressed line by a distance. And string, used to pull the things, we can think of a string as a spring with a force constant so large that the extension of the string is negligible. Next. What is the body diagram? Free body diagram are diagrams used to show the relative magnitude and direction of all force acting upon an object given situation. This diagram will be used throughout our study Syauqi. The size of the arrow in a free body diagram reflects the magnitude of the force. The direction of the arrow indicates the direction of the acting force. Next.
And then for the next material, which is daily problem involve Newton's law, will be explained by Ali and also Nababi. But for the first and second law will be explained by Nababi.
Daily problem involved Newton's law. Example of inertia involving aerodynamics. 1. The motion of an airplane when a pilot changes the throttle setting of an engine. 2. The motion of a ball falling down to the atmosphere. 3. A model rocket being launched up into the earth. 4. The motion of a kite when the wind changes. First law, and also its application on a simple pendulum. Other application is phase wheels braking, which causes a person to be passed backwards while in a car. Second law. Example of force involving aerodynamics. An aircraft motion resulting from aerodynamic force, aircraft weight, and torque. This is an illustration of the application of Newton's second law. The application of Newton's second law in everyday life is very much like when we pull a chair from one point to another. The tensile force given to the chair will be proportional to the value of the object acceleration, which will have an impact on the movement of the object.
And then for the third law will be explained by Ali.
Okay, thank you, Marshanda. Third law. Example of action and reaction involving aerodynamics in third Newton's law. 1. The lifting motion of the airfoil. The air is deflected downward by the action of the airfoil, and as a reaction, and wing is pushed up. 2. The motion of a spinning ball. The air is deflected to one side, and the ball reacts by moving in the opposite direction. 3. The motion of the jet engine produces thrust, and the hot exhaust gases flow out from the rear of the engine, and the truth is generated in the opposite direction.
And then we jump to the end section, which is the summary of the Newton's theory. So as we know that Newton consists of three laws. The first is first law, second law, and third law. First law, known as a law of inertia, where moving objects keep moving, objects stay at the rest, will stay at the rest, unless acted on by unbalanced forces. And the second law, expressed by the formula of force equal to mass multiplied by acceleration, where more force means more acceleration, and more mass means less acceleration. And the third law, known as action-reaction law, if an object exerts a force on another object, the second exerts an equal and opposite force on the first object. After all the material that we already delivered for you all, we arrive at the end of session of presentation. But before we leave, anybody has question related to the material? If there's nothing, let's jump to the last session, which is closing. Thank you for your attention. Well, that's the only presentation we can deliver. Sorry if there are still many mistakes and shortcomings during the delivery process. Lastly, physics is essentially intuitive and considered science. Assalamualaikum warahmatullahi wabarakatuh.